Here's the problem that we wanted you to do. Problem 8.9 in the old first edition, now called 8.10 in the second edition. It's an inversion recovery. That is, I start with a pi pulse. I will then have a pi over 2 pulse to get a signal started. And I'm going to use a spin echo to try to recover the signal. I'll recover that signal, then, this pi over 2 pulse occurs at Ti. Then I'll have a pi pulse at some tau seconds later, and then at Ti plus 2 tau, I get a spin echo. I get a recovery. I get some of my signal back. Now, there's a neat thing to remember here, and a lot of the things that we've been doing here in Chapter 8, we again need to only focus on MZ because there's no M-perp. At the beginning of any experiment, there's no transverse magnetization. There's none. Then I get some at pi over 2. And then whatever happens here, I'm taking TR much greater than T2 so that the transverse magnetization is dead. It's gone by the time we're repeating the experiment. So then it starts over with no transverse magnetization. Later on in the course, we'll look at some interesting fast imaging where the magnetization the transverse magnetization will be there too, making it a richer problem. We can here, however, we need only focus on MZ because there's no M-perp going into each pi over 2 pulse. We are striving, however, for our signal, our M-perp, at this echo, the 2 tau, Te equal 2 tau. But no matter how many times we go through this sequence, we'll always start out right here. Right here, we're going to tip. There's only going to be longitudinal. We're going to tip it completely. There'll be no longitudinal left, right on, when we're always putting these plus and minuses, you know what we mean by that. That this is just, an infinitesimal incremental time after the pi over 2 pulse. I've got no longitudinal. And if I have a minus there, it's just before the pulse. So we're going to get the same answer for MZ at every NTR minus, no matter how many times we go through it, because every time we go through it, we're really going to have 0 longitudinal right here, and we only need to worry about MZ. And so if I do this once, I'm set for the rest of the time. Let's go through it then once. At pi over 2, I've got then 0 MZ. And every time we're going to use the master equation for recovery. Here it is. Right after this pi over 2 pulse, when we get just before the pi pulse, here we go. We had 0 initial. Here we got recovery at the pi pulse just before it. Here's our recovery of our MZ. Then at the pi pulse, remember this is the pi pulse for our spin echo. This is just the negative of this. So it's just minus this. Then we'll evolve this. After this thing now, nothing else is going on, so I can just freely evolve that MZ, recover it as much as I can. Here we go. To recover it starting from just after this pi pulse, I've got the initial value times the appropriate exponential in our master recovery formula, plus m0 times 1 minus that exponential. And this time is just the time that has evolved, from this point out to TR. Next, I've got that guy at TR, but it's at TR minus, and because now the next time through, I've got that inversion pi, and it's going to flip that thing. Well, first of all, I just rewrite this here to make it a little neater, because I can combine two of the exponents, two of the exponentials. And now, at the first pi pulse, it just goes to negative. Whatever this mess is, it's just minus that mess. And then I evolve that. See, now something new has happened to MZ, so I've got to use a new recovery discussion. I'll go from recover this up to the pi over 2 pulse to see what I'm going to be able to get as a signal by tipping it. So I've got mz just before that pi over 2 pulse is our good old recovery. I've got minus m0. Oh, you know what I've got here? I've got this whole thing here, and then I have the appropriate exponential, e to the minus ti over t1. So I've got this thing, and then you'll combine it. And now this is what I've got to tip. So at the pi over 2 pulse, I've got that mz to tip. And I'm not going to write it again because if I keep writing anymore, I'm not going to give you anything to do. But what you'll know is, whatever this mess is, that's your mz, that's what you can tip. You'll tip it, and then it decays. But it doesn't decay with a T2 star. At the echo, it decays with T2. That's the whole point of using that echo. And so it's easy to get then. You've got that mess times e to the minus te over t2, and of course te is 2 tau. And the answer is given to you in the book, so you can check against.